An electrolyte is a substance whose aqueous solution will conduct electricity. An aqueous solution, again, means something that is dissolved in water. For example, we looked at NaCl. We would write the physical state AQ, meaning it's aqueous. So an electrolyte is when you have an aqueous solution and it conducts electricity. Electricity is the flow of electrons. And one way we can test if we can conduct electricity is by using a light bulb. And we can classify electrolytes as strong, weak, or non-electrolytes. Depending on how much they would light up a light bulb, depends on how many electrons are going to be present or ions are present in the solution. So you will be doing an experiment, experiment 10, which is on the conductivity of different solutions and classifying them as strong, weak, or non-electrolytes. So a strong electrolyte is a solution when you dissolve it. Well, it's dissolved and you have ions present. You have lots of ions. And it's these ions that came from transfer of electrons. So we have this flow of electrons going on that we would get a very bright light bulb if you were to test its solution. Weak electrolytes, there are few ions present. So if you were testing the solution to see how much electricity you could produce, you would get a very dim light bulb. Non-electrolytes are substances that dissolve in water, but they don't form any ions, so there's no ions present. So we cannot conduct electricity with a non-electrolyte. So we're going to look at those each in more detail. Strong electrolytes are compounds when you put them into water completely dissociate into ions. They're very good conductors of electricity, so you would see a very bright light bulb if you were testing their solution because there's lots of ions present. An example would be as we looked at sodium chloride. Sodium chloride, we learned when you put it into water, we learned how water actually dissolves it by having that partial positive hydrogen end, the partial negative end, breaks apart our sodium chloride into sodium ions and chloride ions. It 100% forms these ions. So in a solution, there's lots of ions present. So this would be an example of a strong electrolyte. So any ionic compound that dissolves in water, meaning it's soluble, would be a strong electrolyte. Strong acids are another example of strong electrolytes. So there are 6 strong acids listed here that you need to remember. Our next chapter that we're going to be covering on strong acids and strong bases and weak acids, weak bases, you'll have to memorize these 6 strong acids. So I'm introducing this now so you can start learning the 6 formulas. A definition of an acid is something when you put it into water, you form hydrogen ions. And we'll learn more in chapter 8 about that. But notice with all these compounds, they all have a hydrogen written in the front. So when we put them into water, for example, if I start with the first one, we have HClO4. When I put that into water, that compound, it would form 100% ions. So we have aqueous ions. Hydrogen ions, and then we have this polyatomic ion, not one of the ones you have to know. Okay, so that would happen with all of these 6 strong acids. So to help you remember the names, or not the names, the formula of the 6 strong acids, I had a student that came up with the way that they remembered it, and it was I close closets, so no breeze. And we know that all of our acids are going to start with hydrogen. That tells us we have an acid in the front. And then the first letter in each of these, so we have I, and that would represent HI. We have Cl in close, that would represent HCl. And then we have ClO, that would represent HClO4. And notice this is plural, so it has 4 oxygens. And then S would represent our S in H2SO4. And then the N is in HNO3. And then the Br is HBr. So a couple of these, we've learned the polyatomic ions before. We had NO3 minus is nitrate. Not that you have to remember, but that might help you remember. HNO3 is actually hydrogen and nitrate ion. The other ones are single, except HClO4 is a new one. And then we have SO4, which was sulfate, SO4 2-. So to balance that, it's going to take 2 hydrogen ions. Hence, we have H2. So you need to know the formulas of the 6 strong acids. So if I was to give you a strong acid, I might ask you, is it strong, weak, or non-electrolyte? Strong acids always form a whole bunch of ions, so they're going to be strong electrolytes. This slide shows us at the molecular level what our strong electrolytes look like. So we have sodium chloride on the left here. And sodium chloride, again, we have a white solid salt. When we put it into water, it breaks apart into 100% ions. So it's showing you that our ions are separated here. So we have all these ions floating around, so that's going to be a strong electrolyte. Hydrochloric acid is HCl, the one on the right. This is one of our 6 strong acids. So again, hydrogen chloride gas, if you bubble it in water, you're going to get hydrochloric acid. And that's going to be, again, separated 100% into ions. We have chloride ions and we have hydrogen ions. So due to all those ions present, lots of ions means it is a strong electrolyte. Weak electrolytes are compounds that partially dissociate when you put them in water and form only a few ions. And because there's only a few ions present, there's only a very small amount of electricity that's conducted. So because there's such a small amount of ions, we would get our light bulb to light up, showing we're conducting electricity. But because there's just such a few ions, you're not going to get that bright light bulb you would with a strong electrolyte. An example of weak electrolytes are weak acids. One example of a weak acid is acetic acid. So you may ask, how do I know the difference between a strong and a weak acid? How you're going to know that you have an acid is, first of all, I'm always going to put hydrogen as the first element in the formula for your compound. And then when you dissolve it in water, we know the physical state is aqueous. So hydrogen and then some anion over here where it's polyatomic or a monatomic anion is going to tell you that you have an acid. Hydrogen will always be written first. So you had to memorize the 6 strong acids. If I have something written in this format, I have hydrogen first and then some other type of anion here. Notice there's also hydrogen written in the middle here. But hydrogen, the first spot, tells me it's an acid. So if it's not one of the 6 strong, by default, you're going to determine that that's a weak acid. So there's not a list of weak acids you have to memorize. There's a whole bunch of them. You have to know the 6 strong, and by default, you can figure out your weak acids. So anyways, acetic acid, which is the component in vinegar that gives it acid flavor, acetic acid is a weak acid. So when I have this compound and I dissolve it in water, 99% stays together as a molecule. It does not form ions. Only about 1% of this molecule breaks apart into hydrogen ions, and then we have this polyatomic ion here, which is called acetate. So there's a very small amount of ions that are produced, and those few ions are what conduct the electricity, giving us a weak electrolyte. As far as classifying when you're doing your OWL homework, they say whatever you have most of, they call that your major species. Okay, so that's after I dissolve it in water. The major species stays together as a molecule. My minor species is going to be those ions. So we can look here in our beaker and see what it looks like at the molecular level. So here's my acetic acid dissolved in water. So it's aqueous solution. Electrolytes have to be aqueous solutions. And I have a few ions. Here's a hydrogen ion. Here's an acetate ion, but most of them here are our molecules. Okay, they're not forming any charges. So that's the majority. There's, again, just a very few ions, but almost all of them stay together as molecules. So weak electrolyte produces very few ions. Non-electrolytes are substances when you put them into water, they dissolve, but they don't form any ions. So if there's no ions present, you cannot conduct electricity. So if we were to do our light bulb experiment and our light bulb does not light up, that means there's no ions present. So an example we could look at is sucrose, which is sugar. We know when we put sugar in water, it's going to dissolve. So we can have an aqueous solution of sugar. However, we do not form any ions. It stays together completely as a molecule. So what we started with here, we end up with the same thing. So at our beaker, it shows us there's no ions present. These are all big molecules of sucrose. There's no ions forming. So one way you can tell that you have a non-electrolyte, I said sugar is an example, is if you have covalent compounds. Covalent compounds do not form ions. Now the thing that may be a little bit confusing is if we look at our acids, for example, HCl. That's hydrogen's a nonmetal, chlorine's a nonmetal, so you might think, oh, that's a covalent compound. But when I put it in water, I get this aqueous solution that actually breaks apart into ions. So if I form ions, it's not going to be a covalent bond. So there's really what I would say a third class. We have our ionic compounds, and we have covalent compounds. And then we have this class we didn't learn about, which are acids, and we're going to learn in our next chapter about bases. So your acids, you might think those are covalent, but once they're dissolved in water, they are what I would call a third class of compounds, my acid and bases. So the way you're going to be able to tell, if we look at, for example, sucrose here, sucrose has hydrogen in it, but notice I did not put hydrogen in the front. Again, your acids, how you can tell you have an acid is going to have hydrogen in the front. If it doesn't have the hydrogen in the front, and all my elements like carbon, hydrogen, oxygen are all nonmetals, that will tell us that we have a covalent compound. So that's one way you can tell that you're going to have a non-electrolyte. Again, something dissolved in water that's got covalent bonds is not going to form electricity. So that's your non-electrolyte. This slide shows what your experiment 10 on conductivity of solution lab will look like. Is basically you're going to be testing solutions, and you're going to be using a light bulb apparatus that looks very similar to this. Is you have a light bulb that has got these two probes down here. One has a positive charge, one has a negative charge. The positive is called a cathode. The negative probe is called an anode. And you'll be testing solutions. So for example, if we have salt, NaCl, that's an ionic compound, and we know it dissolves in water. So anytime you have an ionic compound that dissolves in water, it's going to be what we consider a strong electrolyte. It's going to conduct electricity because there's lots of ions present. So what happens is we have sodium ions and we have chloride ions that are going to be attracted to the opposite probe. So sodium ions will be attracted to the anode, and chloride ions with that negative charge will be attracted to our cathode with the positive charge. By having ions in solution, we actually complete the circuit here in our light bulb, causing the flow of electrons here to light up our light bulb. Versus a non-electrolyte, there's no ions present. For example, sugar again is covalent. Okay, so there's no ions. There's no connection here between our probes, so we cannot light up our light bulb. So when you're doing the experiment, if your light bulb does not light up, it means you have a non-electrolyte. This slide shows your light bulb experiment lab at the molecular level. So the first one we have here again, a non-electrolyte. So we have our light bulb apparatus. We're testing our solution here and nothing's happening. It's not lighting up. So it's showing you again at the molecular level here for our compound that everything is staying together as a molecule. So we have water and we have sugar molecules here. There are no ions present, so no electricity going on. The second one here, we have a weak electrolyte. So again, this is acetic acid that we have. Hydrogen's written in the front. That tells us we have an acid. It's not one of the 6 strong ones, so we know that it is an acid. And in this case, we have a few ions, not very many. And then most of them, again, are staying together as molecules. So a few ions, we get that dim light bulb from a weak electrolyte. And then we have the bright light bulb that's coming from our strong electrolyte, which would be an example of sodium chloride, an ionic compound, gives us all ions. So we have sodium ions, chloride ions, and then these are just showing our water molecules. Is deionized water a strong, weak, or non-electrolyte? The answer is non, because deionized means there's no ions. All the ions were taken out of water, so that might be talking about if you had tap water. Is potassium chloride in the solid state a strong, weak, or non-electrolyte? The answer is non. The reason that it's non is because of the physical state is a solid. Our definition of an electrolyte is something dissolved in water, so the physical state needs to be aqueous. So that one, sometimes there's a little bit of confusion. Make sure your solution is aqueous. KCl is an ionic compound, but in this case, it's a solid state that's not going to conduct electricity. KCl aqueous is a strong, weak, or non-electrolyte. This is the example where we have strong, and this is because we have an ionic compound that's dissolved in water. We have H₂SO4 aqueous. This is known as sulfuric acid. Is this a strong, weak, or non-electrolyte? The answer is strong, because this is one of our 6 strong acids that you need to remember. Anytime you have a strong acid, that's going to be a strong electrolyte. H3PO4 aqueous, known as phosphoric acid. Is this a strong, weak, or non-electrolyte? The answer is weak, because this is a weak acid. And again, you know it's an acid because I wrote hydrogen first, and the physical state is aqueous. C₃HO in the liquid state. Is this a strong, weak, or non-electrolyte? The answer for this one is non, because this is a covalent compound. So I also said they need to be aqueous phase. A liquid, there would be movement. So if there was ions, they could move around as well.